So in this experiment I'm going to investigate the reactivity series of metals using displacement reactions. Now a displacement reaction takes place when a more reactive metal or element takes the place of a less reactive element in its compound. So for this experiment I'm going to look at the displacement reactions of metals, and I'm going to react metals of different reactivities with metal salt solutions, specifically nitrate solutions. Okay, so on the screen is the template for the experiment, and there are a couple of questions there. So just pause the video and have a look at these questions. Once you've answered them, restart the video and watch the rest of the experiment. So I'm going to do the experiment in micro scale. So I'm going to do the experiment on this little tile, this dimple tile, and I've put some copper into 3 of the wells, some magnesium into 3 of the wells, and some zinc into 3 of the wells. And what I'm going to do is I'm going to add the nitrate solution of each of those metals, plus also silver nitrate, just to have a look at any evidence of any chemical reactions. So first of all, into this row here, I'm going to add some small amounts of copper nitrate, so to the magnesium and to the zinc. You can already see some evidence of reactions, some colour changes on the metal surfaces. To the second column I'm going to add some magnesium nitrate. So add some magnesium nitrate to that copper and to the zinc. Then I'm going to add some silver nitrate to all 3 metals. And then finally I'm going to add some zinc nitrate to the copper and to the magnesium. So for these 4 metals we would expect the most reactive element to be magnesium, followed by zinc, followed by copper, and then silver being the least reactive of these 4 metals. So therefore here, where we've added copper nitrate to magnesium, magnesium is more reactive than copper, so magnesium can take the place of the copper to produce magnesium nitrate and copper, and the copper that we're producing is more of the sort of black copper oxide, but you can see there that there's a coating on that magnesium. Again here, with the zinc and copper nitrate, zinc is more reactive than copper, so zinc is taking the place of the copper, producing zinc nitrate and copper. In this second column, we've added magnesium nitrate to copper, so magnesium is more reactive than copper, so copper is unable to take the place of the magnesium, so we're ending up there with just the same as we had to start. And again here, with the zinc and magnesium nitrate, there's no reaction there because the zinc is less reactive than the magnesium. In this third column, we would expect all of these to react because silver is the least reactive, and indeed we can see here that the copper is getting coated in a layer of silver, and therefore we have produced copper nitrate and some silver on the surface of that copper. Again with the magnesium, magnesium far more reactive than silver, so we'll produce magnesium nitrate and silver. And then finally, with the silver, zinc is more reactive obviously than silver, so we will produce zinc nitrate and displace the silver from the silver nitrate. And then finally, with this experiment here, we have copper with zinc nitrate. So copper is less reactive than zinc, so is unable to take the place of the zinc, and so we keep the same experiments, the same substances. And then finally here, magnesium and zinc nitrate. Magnesium is more reactive than zinc, and so therefore we have produced magnesium nitrate, and there is some zinc, some darker grey colour forming on the surface of that magnesium. So as we would expect in these reactions, the more reactive metals take the place of the less reactive metals in their compounds, and so that's the use of displacement reactions to show an order of reactivity.